Hey everybody, Ugly Shader here with another YouTube video tutorial. And as you can tell by the title, of course, we're going to be, getting our introduction to drivers. Now, I was originally scared off by drivers in Blender for the experience or for the reason that I have experience with some other applications that had basically driver functions. However, in order to properly utilize or implement those driver functions, you had to know a fair bit of the programming language that the application was written in. And I just kind of expected the same of Blender. I do know some C Sharp, C++, a bit of Windows Forms, and like GTK and stuff, but I hadn't learned Python, and I didn't want to have to learn Python while learning Blender, so I just put off drivers. Turns out it was a really, really stupid assumption, and I should have just actually looked at how Blender did it because drivers are a breeze in Blender. I mean, in some ways there are some complicated aspects to them, but setting up and implementing your drivers is normally as simple as just point and click, and on occasion maybe typing a little bit in one of these small boxes. But it's nothing complicated. There's not really anything you got to worry about memorizing or anything like that. It's actually quite simple to use drivers in Blender. Now, this is a re-recording of a video I did a few days ago because I myself am still pretty new to drivers and I made some pretty bad mistakes while recording the video, so I figured I'd just upload it again. And on that thought, if you guys ever happen to notice mistakes that I make in my videos, like um, real mistakes, if I accidentally said uh, uh, black instead of 0 when referring to the numerical value of a color or something, we can let that slide. But if it's like an actual error where the information I'm giving is straight up wrong, yeah, let me know. Blender's tough enough as is. We don't need wrong information out there. So yeah, if you notice something I did wrong, let me know so I can fix it. Anyhow, yeah, drivers are super powerful. Basically, what a driver does, it allows you to control a variable with another variable. And right here, and this is almost kind of going to be like a little promo for procedural sky, but what's currently appended into my environment is what's known as Sky Free. And you can just Google it. It's a free procedurally generated sky that you can download, and all you have to do is append it to your scene. And yet, no images required, 100% procedural. And one of the coolest things about this particular node group that you can use as your background is that the way they set it up is very driver oriented. So as you append it to your scene, you get the procedural node group texture set up, the material that is your world environment. So if I go to my node editor and then click on the world tab, you can see we have this rather, well, kind of ridiculous procedural texture. Now, mind you, the skies that I use in my render is based off of this, but I've added like at least twice as much as what's already here to it just because I'm a really big fan of having just, lots of control. I like a one tool fits every job kind of situation, so I've slowly been trying to build a sky up with more and more and more control just so that yeah, that one tool fits every job kind of thing. It'll probably never be perfect, but it's nice. Anyway, oh, well, I guess I should leave that open. Something you may have noticed in this material as it was up on the screen is that there were quite a few of these boxes, these value input boxes that traditionally have a white or gray background. Quite a few of them are purple. And that purple is actually an indicator that there is a driver assigned to that number. So everywhere you see one of these purple things, there's actually a driver assigned to it, and I can't change the value. I can click on it and drag it, and it'll change as I drag it, but as soon as I let this value go, it's going to return to its original value and give me an error telling me that I can't edit a driven number. And yeah, it's because it has a driver on it, and this value is no longer controllable by us. It is now controlled by something else, whether it be a different variable, a different one of these numbers somewhere in here that when it changes, it will also change that, or it may be a custom property. Or it could be something like a transform, like the rotation or location or scale of something may be what controls this value. So yeah, it's all about using one value to control another value. Well, the way they have this particular procedural sky set up, we'll shrink this down and I can get rid of you. Anyhow, the way they have this set up is this sun lamp right here that is part of the sky free node group. If I come over to my properties window and click on the object tab, you can see I have a huge list of custom properties. So scoot that over and we drag this out so we can actually read them. And you can see we have animate, sunset, sunlight and rotation, red, turbidity, rotation. Oh, sky rotation, sun rotation, and sky rotation. I was like, I thought I already got to rotation. Anyway, so yeah, all these sliders are different control values for this procedural sky. And if I look up at the very top, you can see we have a sun up here, and there's clouds and everything like that. Well, if I grab this animate slider, as I drag this animate slider, you can see we actually have animated clouds. And they're, excuse me, but they're not just sliding across the screen, they're not just images of clouds moving. They're actually forming and dissipating and reforming, and clouds are forming in different spots than where the original clouds were formed, and it's actually like, clouds. So when it comes to like animating nodes and stuff, I mean, in this particular node group, we'll just full screen you. Oh, wrong one. So in this particular node group, we have well, actually that's for the Sirius clouds. That's not what we're looking at. This here. All of this here is for the clouds, as well as this mapping node here. So it's entirely possible that in order to achieve this particular effect in the animation, that this one slider is controlling more than one value in this node group, and that creates a lot of potential and a lot of possibilities, as far as there are many things that you can control with a single slider. And that means that either you can achieve effects like this, where 2 or 3 different math functions are all working together at the same time but with different values because of how you've set your variables up, to achieve the appearance of animation or something like that. And then there's many other possibilities with it. For example, here we have our sun, and that's not actually the sun. That's just part of the procedurally generated texture. It's just a spot in the sky. The actual sun is our sun lamp right in the middle of our grid here. But if I look up at this sun and grab this sunset option and drag it, let's turn so we can actually see it go down. You can see the sun sets, but not only does the sun set in the sky, as the sun sets in the sky, the tint and color and brightness on the back of the clouds is changing, the turbidity in the environment is changing, the color and brightness of the background texture itself is changing, the color of the sun is changing. So as you can see, a lot of values are being controlled by this single slider. So in a situation like this, where everything's pretty much pre-calculated, the sun's going to get darker in appearance as it gets further down towards the horizon. The sky is going to darken. The appearance of the clouds is going to change, because we can figure out how we want all these values to change ahead of time. Hooking them up with drivers means that instead of going into our node group and changing the values on like 25 different nodes, little bits by little bits, every time we make a change in the environment, instead it's just a single slider. So a little bit of extra time to set something up at the beginning of what you're doing can save a ridiculous amount of time later when it comes to fine-tuning and making adjustments in your scene. So yeah, this is one of my preferred examples on the power of drivers, just because you can control one variable with another variable. But not only can you do that, you can control a whole stack of variables with a single variable. So yeah, drivers are very, very powerful. Very powerful. Now, mind you, we're not doing anything nearly this complicated today. Today, we're just going to go ahead and make a driver setup that, well, here, we'll go over it real quick. Our scene needs a plane, and we'll just scale this up to about the size of the grid floor. And then we need a cube, and we're going to lift this up. And the only reason we put a plane in here is so that we can reference the size of our cube as our cube grows. It's just easier to keep track of if there's another object in the scene that we can compare it to. Let's give us something, kind of soft on the eyes for a world environment color. Just kind of a light blue. Not quite that bright. That's better. Just so that, we can kind of see what's going on a little better. And let's add a lamp so that our object doesn't horribly blend into our background. And we're just going to add a sun lamp, and I'm just going to give it a little bit of rotation. I want it cutting across the plane at like a 45-degree angle, and I want it coming down from the sky towards the ground as far as the path of the light at like a 45-degree angle. So I'm just going to do a 45 and a negative 45, and that should do pretty good. See, and now the sun's back over there somewhere in a sense, and it's shining this way across our environment. All right. Well, so yeah, what we're going to be doing is setting up an object, wrong menu, so that the material we put on our object doesn't get distorted or stretched out or destroyed or anything like that as we increase the size or decrease the size of our object. So I'm just getting set up here. The 3 windows we're going to need, I didn't do anything with my time. I never remove my timeline. Anyway, the only 3 windows we need for this particular tutorial or example is the 3D view window. We will need a node editor so we can set up some materials. And then in order to set up and control the drivers, we're actually going to use our graph editor. So these will be the 3 windows that we work in. Alright, so let's select our cube and get a material on it so we can see the problem that we have. Alright, so there's new material on it, and we're going to keep this really simple, like really simple. I'm just going to put a checker texture on it. And a checker texture works really good because it's comprised of even squares. So if anything doesn't work right as we're setting up our drivers, we'll probably know right away because either our squares will grow or they'll distort. So here we have a cube, and as we make the cube larger, the pattern grows with it, technically. Like the size of the squares becomes larger proportionate to the increase in size of the cube. Well, sometimes that's fine. Sometimes that works out quite all right for you and it's no big deal. Other times that can actually really be a big problem. Like, for example, say this was a plank, like a piece of wood for a hardwood floor. And as you're working on it, you realize your proportions are a bit off and that your planks aren't as long as they need to be for as wide as they are. But that means that as soon as you grab that plank and stretch it out, you're also going to stretch out the wood texture on top of the plank, thus distorting it and taking away any aspect of realism or accuracy that it may have had. So that's a problem. Now, the traditional workaround for doing something like that, like if we stretch this back to 1, there's our checker pattern, and then say we stretch it out on the x-axis to there. Well, the traditional workaround to get your texture pattern back where it was would be to come over to your node editor and go into vector and grab yourself a mapping node, and then grab yourself a input category texture coordinate node. And let's go ahead and plug the texture coordinate node into the mapping node, and then plug the mapping node into the vector. And now what we do is we come over here and we look at the object, and then we look at the scale of the object. Well, the scale of the object is 6.278. So we need to come over here to the corresponding scale in our mapping node, the x coordinate, and set the x coordinate to 6.278. Wait, no, 287, my bad. 287. And there's our solution. Now, because the scale of the texture on the x-axis equals the scale of the object on the x-axis, we no longer have a problem with our texture being stretched out. However, that's a complete pain. I mean, every single time you have to make any adjustment on this object, especially if it's an object you're messing with a lot, you're going to have to come in and change the scale values on the texture to equal the scale values on the object itself. And yeah, that can get old really fast, especially if you're making a lot of changes on that particular object. And that's a big waste of time. I mean, time that you could be building the rest of your scene or moving on to the next problem you need to fix. It's just, as a 3D artist, the less time you have to waste, the better. So in a situation like this, we can actually, when we first, get our objects set up and get our texture set up, we can spend a little bit of extra time and set up some drivers to automatically control this variable with one of these variables. And that way, later on, anytime we make these changes to the object, we don't have to worry about coming through and adjusting every little aspect of our material just so that everything keeps looking the same. And I mean, there's lots and lots and lots of other potential uses for drivers. This is just very, very basic beginnings. Try to get your foot in the door and get you a decent feel for the fact that they're not too complicated, and how to kind of set them up and maybe start exploring and playing with them on your own. So what we need to do in order to make this work is, well, the first step in setting up a driver is determining two variables. And, I don't want to scare you off with the word variable. All I'm talking about is numbers. Two different things that could change. And we need two of them. We need something that changes automatically. In this case, we want these to just automatically change anytime we change something else. And that is the other thing we need, the other number. We need what is going to change automatically, and then what is going to cause that to change. So if, as this cube rotated on the z-axis or the x-axis or something, as it rotated, say we wanted our pattern to grow, well, this would be what is causing the change, and this is what is automatically changing for us. So those are the two things we have to figure out when setting up a variable. What is going to cause the change, and what is going to experience the change. Well, in this particular situation, since I've already told you what we're going to be doing, we know what we need to use. First thing is going to be this mapping node. We know that as this cube grows in scale or dimension, as these numbers increase, we also need these numbers to increase. So these are the ones we want to increase automatically, and the ones that are going to control those will come from here somewhere. So there's our first step. We know what we're going to control and what is going to control it. The next step is just building our drivers or setting our drivers up. So we come over to the numbers that we want to be controlled automatically. And that'll be these three numbers. And to add a driver, all we need to do is right click. So we go ahead and right click, and right here in our list is an add driver option. Now we have all from target, single from target, matches, manually create later, and manually create later single. Now for this tutorial, and honestly I'm still pretty new at it, but like every single time I create a driver so far, the manually create later option seems to just be what I go for. It seems, in my opinion, it's probably the easiest to understand. It covers, a lot of the different aspects of what a driver is, and it's just, I just like it, I guess. So, for our manually create later, we have two different options. We have just plain old manually create later, and then manually create later single. Well, if I click the single option, it's going to put a single driver on whatever variable I chose. And as I mentioned near the beginning of the video, when there's a driver associated or attached to a variable, or just attached, sorry, not associated, because technically associated would mean like, this number that's making the change. Well, that's technically associated, but there is no driver on that, so it won't be purple. So yeah, whatever variable your driver is attached to turns purple. Now, I'm using I think the default color scheme. I might be wrong, but it's entirely possible that if you're using a different color scheme, this will be a different color. Just like with the default color scheme, if you insert keyframes and stuff like that, you get yellow and everything. Well, default, I believe, for drivers is purple. And yeah, so you can go through and click and just add a single driver to each if you would like, or if you just want all of the drivers in a particular section, or all of the variables in a particular section to have drivers, you just add drivers and manually create later, but don't pick the single option, and that'll just give one driver to each variable in that little box. And yeah, if you need to get rid of drivers, you can just right click them again and you can delete all the drivers in the box, or you can delete a single driver. Now, keep in mind that the order in which the drivers are added will determine the order in which they show up when you're working on them. So because I deleted this X driver out of the list of X, Y, and Z that were in that order, well, now the list will have Y and Z. And if I add this X driver back in as a single driver, well, now when I go look in my graph editor at my drivers list, my list is going to be in the order of Y, Z, X, because that is the order I ordered or added the drivers in. Now that's not going to change their functionality or anything like that. It's just going to change the order they show up in the list. So if you're, really particular about that, or that's the sort of thing that might confuse you, just try to be mindful of the fact that you should add your drivers in order then. All right, so add drivers, manually create later. So each one of these now has a driver, and they are all independent of each other. The X driver only controls X, and so on and so forth. So we've covered step 2. Step 1, we figured out what numbers we're going to use, where the drivers need to be, basically. Step 2, we put them on there. Now let's set them up. So we come down to our graph editor, and just like in our 3D window, or our 3D view window or whatever, we have a mode option, object mode, edit mode, vertex paint, so on and so forth. Well, over here in our graph editor, right here where it says F-curve, that's actually a mode selector too. And in this mode option, we have F-curve and drivers. So if I pick drivers, all of a sudden we have something in our list. Now it's just going to list out the hierarchy of where the drivers are located. Now mind you, the drivers are located on the mapping node in the material that's on the cube. The drivers are not on the cube. They're not on the material or in the material technically. They are just part of this mapping node. If kind of in a sense, Blender, when you put drivers on something like this, Blender almost views it like it's an object. Like this is an object, this is an object, this is an object, that's an object, the plane's an object, so on and so forth. Like they're all objects. I mean, I know this isn't a real object, and Blender doesn't think it has vertices or faces or anything like that. But if you see here where we have cube and material, well, if I select this texture coordinate node, that goes away. Because even though this node and this node are in the same material, they're not associated with the drivers. The only thing that the drivers are on is this node here. If I delete this node, these drivers are going to go away. So yeah, we have this icon here with cube next to it. Well, this icon represents vertices and faces telling us this is, an object, and it's named cube. Yep, that's its name because we didn't rename it. And then that cube has a material on it. The material is named material because we're really boring today. Alright, so if I click this drop down, you see we have shader node tree. And shader node tree is basically talking about all of this. All the nodes inside the material. This here is our shader node tree. And if we open up our shader node tree, you can see one of the nodes in our shader node tree has drivers on it. What node is it? It's the mapping node. And yeah, we could change the name of the cube, and where it says cube would change. If we change the name of the material, where it says material would change. And if we change this node name, that's going to change. So all of this is just telling us where exactly it is, and it's all named according to the names of the object, material, or whatever node the drivers are on. And that's actually another thing. You can put drivers on a lot of your modifiers too. Array modifiers, remesh, displace, simple deform. Like you could put drivers a lot of places. Anyhow, yeah, I guess it was on there. It doesn't really matter though. So here we have our mapping node, and that's where the drivers are. So when we have our mapping node selected, we can see our drivers. And over here, by default, we will just have a graph. But a graph doesn't tell us much. It doesn't help us set up our drivers. So we'll either need to press the N key or click on this little plus here to bring up the, what is it, the view properties window, I guess. Anyhow, once this window is open, you can see we have 4 tabs here. We have views, the modifiers, drivers, and F curve. Well, we're only going to be playing with the drivers, not playing with any of this other stuff. You know what? I don't even know if their functions are tied yet. Like I said, I'm still fairly new to drivers myself, but they're just so cool. I had to make a video about them. So, alright, over here we have an X scale, a Y scale, and a Z scale driver, and they're on our mapping node, the X scale, Y scale, and Z scale. So let's start with our X. So we have our X scale, and this is our driver setup here. We can drag this up so that we just see these values here, because that's really all that's important right now. Alright, so at the top of our driver box here, we have update dependencies. Now, when we make changes in our variables and our expression and stuff like that, sometimes the computer code that's running in the background that's supposed to control of this doesn't change like it's supposed to right away by default. So we're supposed to be able to click the Update Dependencies button, and that's supposed to just fix everything, force the new code to be changed, or force the old code to be changed to the new code, I guess. Unfortunately, in my experience, it only works about half the time. Sometimes I can get errors in my variable options or even in the variable itself, and I could just hammer this over and over again, and it doesn't fix anything for me. However, I find that anytime I have an error in here where the dependencies need to be updated, all I have to do is either alter my expression or alter the property that my variables are based off of, and it'll fix it. And we'll get to that in just a moment. So underneath the update dependencies, we have remove driver. Just like, right-clicking here and deleting the driver, it'll remove the driver. So nice and simple there. And then we have the type selection for our driver. We have scripted expression, and then 4 other options. Sorry, I was scratching my head and my mouse won't sit still. Anyway, so we have scripted expression and 4 other options. These 4 other options, the maximum, minimum, sum, and averaged, are all drivers that have predefined mathematical functions. I don't really use them, just because the scripted expression option allows me to define my own mathematical functions, so if I need a maximum, minimum, sum, or averaged, I can just do it myself. So for this one and for probably most of the driver tutorials that I do in this series, we'll be using a scripted expression. Okay, so now underneath the scripted expression, we have the expression box. And this is actually where we can do lots of things. This is one of the really powerful parts of drivers. We're not going to do anything too powerful in here today because I don't want to scare you off too much. But yeah, this is an amazing little box with untold potential. And the important thing to remember about this expression box here is that whatever is in this box is what this value will become. So if I change this to a 5, this will become a 5. If I change this to a 3, this will become a 3. Whatever is in this expression box is the value our driver is going to assign where our driver's at. So that's pretty simple, right? Just whatever is here is what this will equal. And then it's up to us to use variables in math or whatever we want to determine what is here. Today is going to be super simple, but yeah, so that's how we're going to handle that. Next, we have a use self option, and that assigns a variable to the driver itself. We're not going to play with that. And then we have the show debug info. And if I remember right, the driver value, the show debug info driver value, will tell us whatever, because we can use multiple variables up here, and we could add the variables together, or multiply them, divide them. We can do all sorts of math up here. And that might be kind of hard to keep track of as far as, what its current value is once it's all just words and math symbols. So this should keep an updated numerical value of whatever the actual value of our driver is. So it just helps you keep track of things and make stuff easier. I suggest leaving it on because it's just on by default. All right, next we have an add variable option, and then our variables as far as the category of where they show up. There are 4 different types of variables, so I'm going to go ahead and add 4 variables in, switch each to its type of variable, and then we're going to go ahead and talk about the different types of variables and maybe a application or two that could be useful for them. All right. Oh, and yeah, you can just click the plus to add variables and click the X's next to the variables to delete them. All right, so here's our 4 variables. Each variable has a name, and we can name them whatever we want so long as for this driver, we don't try and name 2 variables the same thing. For this driver, each variable has to have its own name. However, the variables are driver specific. So, where we have var 001, var 002, and var 003, well, we can set up the Y mapping node to also have var 001, 002, and 003. It doesn't matter because the variables that are on the X driver, this X scale driver, are only on this driver and nowhere else. I mean, we could have 100 mapping nodes, and all of them could have drivers on their on their scales, on their X scale, and all of them could use these same names, and it's not going to matter because the variables are 100% specific to the driver they're attached to. So you don't have to worry about naming conflicts between drivers. That's kind of handy. You just have to worry about naming conflicts on the driver itself. You don't want 2 variables named distance 1. That'll just, confuse things. All right, so under each name for the variable, you have the options to set them up. This first variable is the distance variable, and as you can see, we have a slot for object 1, a slot for object 2, and then their transform spaces. For all of these, they have, well, I guess all except this one here, they have, well, I guess the single property doesn't either. Okay, well, so for the distance variable and the transform channel variable, they have a world space option, or a space option, where you can select the space that the variable's effect occurs inside of. For this, we're going to leave it at world space. For a lot of things, you'll leave it at world space. On occasion, though, you will run across situations in which you will want to change this so that it's a specific space in which the variables function. Anyhow, this first one, our distance variable, as you would guess by its name, we select 2 different objects, and then the variable itself, whatever we have named it, is basically equal to a number, equal to a numerical value. And that number will be whatever the distance between our 2 selected objects are. So if we had 2 cubes that were 4 feet apart, and we were measuring in feet or meters, whatever you'd like to measure in. Anyway, if we had 2 cubes that were a distance of 4 units apart, this variable would equal 4, just whatever the distance between the two objects was. Now, a really cool thing about this is instead of objects, like just, normal meshes, you can assign bones to these. So say you have a rigged character and every time it raises its arms in the air, the texture under its arms distorts really bad, stretches out. Well, you could actually isolate those portions of texture under its arms and assign them to a different material, and then set up mapping nodes on drivers so that as the middle bone in the left hand, as soon as it started moving a certain distance away from the middle bone in the right hand, the texture underneath the arms would automatically start to correct itself so that it doesn't stretch out and look distorted. And that's just a possible use of the distance variable. Very handy thing, I think it could be. Next in line is the rotational difference. And this, like the distance, it's very similar to the distance, only if I remember right, this one's more so just for bones. And like you'd pick two different bones that were attached to each other, and this variable is going to measure the angle between the two bones. So again, say you have a character with I don't know, say your shirt on your character is when the character moves its arms at just the right angle, the shirt on the character is clipping and the character's shoulders are poking through or something. Well, you could actually set up some transform drivers on the shirt in specific areas so that when the forearm bone, or not forearm bone, the whatever part of your arm's closest to your shoulder. I have no idea. Well, I know that that's the bicep muscle. I have no idea what that bone's called. Anyways, so as that upper arm bone angles or reaches a certain angle difference between that bone and the bone that runs up the shoulder towards the neck and stuff, as those bones reach a certain angle or as their angle changes, you use transform properties to help keep your shirt from clipping, or your shoulders from clipping through your shirt. So again, again, my example was for rigging and animating, but still, I think it could be a very useful variable. I haven't gotten to play with it very much because I don't have a lot of stuff with bones in it right now, and again, I'm still trying to learn the ins and outs of drivers. The third one in our list is the transform channel driver, and we're actually going to skip over this one real quick and just go to this one because the transform channel driver is what we're going to be using for this. So we'll come back to that one. Fourth one in your list and last one in your list is the single property variable. And this is the kind of variable that that sky I showed you at the very beginning uses a lot of. This particular variable simply allows you to pick your source, so like we could pick our cube, and then name the path. Basically name your variable. So say we wanted to use the location of the cube as our variable. Well, we'd select the object that had the property we wanted to use, the number we wanted to use, and then we would name that number. In this case, it's just going to be location, but without the capital, so LOCATION, and then we need to tell it which of the three locations we would want to use. Now, instead of X, Y, and Z, the computer looks at these as a numbered list. And this box here that has three options is known as an array, ARRAY. It's a means by which of storing information. So this is its own list. Oops, I didn't mean to click on that. But this is a different list. This is a different list, and so on and so forth. This is the location list, the rotation list. And while a human would count these lists 1, 2, 3, 1, 2, 3, 1, 2, 3, computers don't start counting at 1. Computers start counting at 0. So you have to be mindful of that. This is actually location 0, location 1, and location 2. Rotation 0, rotation 1, and rotation 2. So we can come down here and almost get away with just putting location 0. However, because this is the name of the list and this is the location in the list, we actually have to tell it, to tell Blender that this is the name and this is the location. So for the name, when using one of these array style lists, we can just use its name without a capital, and then to define what position in the list, we use the number. So for x it would be 0, but we have to put brackets around the number, the ones that are traditionally by the enter key, and we just go ahead and put brackets around the number. So now this var underscore 003 is basically a number, and what it equals is the current location on the x-axis of this cube. So if I come over here and grab this cube and move it and, let go of it, you can actually see that the value of this variable has changed to negative 1.615. And if you look at the location of the cube, we're at negative 1.61518, which is this, but a little more detailed. And yeah, so basically, this is our variable, and where it says var003, or as I said, we could rename it whatever we want, where this name is, this is basically, this ASDF I just put there is equal to 1.615. So if I came up here, where the expression is, if you remember I said whatever is here is what this driver will put up here. Well, if I replace this 1 with our ASDF variable, now this is equal to this, which is equal to this, and this will become whatever it is. Now, mind you, here's a situation where things haven't updated, because this still says 1, even though this is not 1. So, clicking it over and over again, nothing's changed, nothing's happened. But if I come over here and scale my cube, actually affect this variable, or any variable, affect a property that this variable is associated with, it seems to auto-update. So now I've stretched that, and as you can see, it's actually changed the size of our pattern on the top. Our pattern has now been scaled by negative 1.615. So as you can see in the mapping note up there, that has also changed. As it stands, though, that is not the driver we are going to be using. So yeah, we're going to be using the transform channel driver. And the reason we're going to use that is because what we just did, it does automatically. For our transform channel variable, all we have to do is pick the object that our property is coming from. In this case, again, the cube. Oh, that never updated. All right, so yeah, we just pick the cube, the object or the location or whatever. Well, in this case, the object that our variable is coming from, that our number is coming from, and we select what type. Since this is going to be the X scale mapping, we'll simply pick the X scale. Click on that, make sure we're just doing that one. So we have our cube and our X scale. It's set for the world space, that is fine. And as you can see, it's red. It turns red when there's something wrong. It's trying to tell us there's an error. Actually, there is no error, it just hasn't updated those dependencies yet. And again, clicking the button isn't doing anything. So if I just come over here and scale my cube and then hit escape to let it go, it fixes. It updates everything in the background. We're good to go again. Okay, so now right here where it says var is equal to whatever the X scale of cube is. So that's simple enough, right? So let's come up to here and replace that. Oh, I hate this keyboard. Like the most sensitive cherry switches in history. I could sneeze on it and type a novel. Anyway, so now we have updated our expression with var. So now whatever the X scale of the cube is what this will equal. So if we come over here and scale our cube on the X-axis, our pattern doesn't stretch out anymore. Our detail doesn't go away. The squares don't change size and become rectangles. They just remain squares. And that is one of the beauties of drivers. Alright, so now let's go ahead and set up the rest of those. But I'm actually going to rename these because I like things to have names. So scale x, and because I changed the name of the variable, I now have to change that up in the scripted expression, or Blender will have no idea how to handle it. It reset the value of our scale to 0 and gave us an Python error on our expression. So yeah, if you make a change in a name on a variable, be sure to make sure you make the same change everywhere else that that variable was used. And I screwed up typing that again. Alright, so now if I come back over here, fixed. Alright, so yeah, now we just got to set up our Y mapping. So same thing. Our object that our change is coming from is the cube, and it's going to be the scale of the cube. So let's go ahead and pick our cube, and this time it's the Y scale. And we can just call this scale Y. And now we come up and we tell the driver that we want to use our variable to control that. So scale Y. And again, throwing an error, try to update, fail, scalar cube, press escape, fix. I have no idea what's wrong with the dependencies button. It might just be my version of Blender. It's 2.79BH, just sub 6.4G, so I don't know. But maybe it's just my version that there's just a bug somewhere that's stopping the update dependencies button from actually forcing the update. But still, it just if you have problems with that, just change a property on a value on the object that your variable's coming from, and that should take care of it. All right, so there's our scale Y, scale Z. We pick our cube. This time we want scale Z. This is scale Z. Wow, did it again. That I can't blame on the keyboard. That's just bad timing in my fingers. SCALEZ. Okay. SCALE. Yeah, Z. And play with it. All right. So there we have it. We have a cube, or an object. It could be any object you want. And no matter which axes we stretch that object on, we don't distort, stretch, or mutilate our texture. Our texture, our material stays consistent. Whatever detail it may have had, this could be a gravel walkway, and now as we extend the walkway, there's just more gravel instead of our gravel stretching out into weird, like, sticks of gravel. It could be a sandy beach or a pebbly beach or something, and as we make the beach larger, the pebbles just, the number of pebbles increases. It doesn't stretch our pebbles all the way up into giant rocks or something like that. And every single time we make a change, we don't have to go in and adjust our material. It just does it for us. So yeah, huge time saver. Now, mind you, it took us a while to set this up because this is a lesson we're trying to learn about it. But if you have the hang of this, setting up something like this for a simple material, you're talking a matter of just a minute or two to throw the variables on and just click a few things real fast. And like I said, you didn't even have to change the names. You could have just left them at var and just typed var in there real fast. So a couple quick clicks, a few letters, and you're saving yourself piles of time later on. Now, a particular problem that you may run into with this situation is, say at some point you've stretched this up and you're like, yeah, it's great, that's perfect, it's the right size. Now I need to apply the scale so that I can rig it and animate it. Let me just hit Control A and apply rotation. Shit. Game over. Just totally screwed everything up. Because our calculations, these right here, were based off of these. And when you apply the scale, it resets it to 1. So right there's a big problem. Now, the two ways to handle this problem, and neither of which is very complicated. The first way, I don't know if it's the better way, but I think it's the simpler way. The first way is that you simply wait until you've gotten your object close to the size you want it, I guess, to apply your scales. Or I mean to apply your drivers. Basically, make sure you apply the scales of your object before you set up your drivers. But that might not work for you in every situation. So there is a second, and in my opinion, a better workaround for the situation. Now we have our drivers set up, and they're set up with the transform channel variables running off of the scale. And I did that because, as you can see in this list, there is no dimensions. Now, if you spend a lot of time rigging and stuff like that, you'll know that when you change the scale of an object and then reapply its scale so that it resets the scale and rotation and stuff like that back to 1, it does not affect the dimensions. The dimensions of the object stay at the changed value that they were at. So, in order to handle this so that no matter how many times you have to apply the scale, you don't screw up your material, I suggest we set these up on dimensions, using the dimensions for our variables instead of using the scale. So let's just come into these real quick and let's get rid of these transform channel variables. And I guess we could set all these back to that 1 they were at for a default. And then we'll just play with you real quick to make sure everything's updated. All right, so add a variable to you, add a variable to you, and add a variable to you. This time we are going to use the single properties. Now, in this transform channel, we can't call to this dimension, and I think that has something to do with the fact that in this particular version of Blender, in older versions of Blender, it was actually different, but in 2.7 and in the version I'm using, you actually can't assign a driver to the dimensions. You can't change the dimensions with a driver. You can change the scale with a driver, the rotation with a driver, the location with a driver, but for some reason you can't change the dimensions with a driver. And because of that, I think that's why the default transform variable does not have dimensions listed in it. Now, mind you, there's a lot of things you can't control with drivers, like I can't control this lens with a driver, the view focal length or whatever. Can't control that with a driver, but that's okay. There's so many things that you can control with drivers that it's not really that much of a problem. Wow, I can't control Z that, really? I think it was a default of 35. Like I said earlier, though, I mean, you can control a bunch of the modifiers with drivers, pretty much everything in a node with a driver, a whole bunch of stuff in your object properties with a driver. So the fact that there are a few things you can't control isn't that big of a deal. But yeah, I'm pretty sure that's why you cannot select X, Y, or Z dimensions on the transform channel driver. So yeah, we're going to work around that just by using these single property drivers that we explained, or that I showed you earlier. So, and for the sake of ease, we're just going to leave them all at their var. So we can just come back here and go var, var, and, oh, I click on you, var. Okay, so yeah, our property, basically our object, only it says property because you don't have to use an object. Well, yeah, I think you can use a bone, and I think there's a few other things you can use. Like you can use lamps. You can probably use empties. In fact, yeah, I know you can use empties. So yeah, this one opens up a few more possibilities. Anyway, our property, our object, is going to be our cube for all 3 of these. So let's just go ahead and grab our cube for all 3 of these. And then our path is going to be our dimensions. So just dimensions, and then for this one it'll be 0 in brackets. This one is dimensions, and I'm sorry I said it out loud because I'm a horrible speller and I'm sure I'm going to make a mistake. Yeah, I already did. Dimensions. Alright, and then bracket 2, no, 1. Go 0, 1, 2, not 1, 2, 3. It might just be because it hasn't updated yet. Dimensions. Yeah, that's right. Alright, so third one, Dimensions. Dimensions. And you're number 2. So now if I scale you and hit escape, well, we got a bit of a problem, don't we? You turn to 2, you turn to 2, and you're 0. So I'm going to say, yeah, there was an error. I didn't get var properly typed up into there. So let's scale again. And technically it worked, but they're all double what we want them to be. And I don't know if you noticed or not, but that's because by default, when Blender creates a cube, these objects, its scale is always 1, its dimensions is always 2. So technically, its texture, its material is double scaled for what we want it. But that's actually really easy to fix. And that ties in with how powerful this little expression box is. Well, if we look at our cube and we compare the scale to the dimensions, well, scale is at 1, dimensions at 2. Scale is at 2, dimensions is at 4. Scale is at 5, dimensions is at 10. Dimensions, because when it started, scale was 1, dimensions was 2. Currently, our scale is always going to be half of what our dimensions are. Or our dimensions are twice what our scale is, no matter how you'd like to look at it. So all we have to do is, in order to fix it, to make it so that, it's actually the right size material again, is we just have to divide this in half. And we can do that in our expression window and with just basic math symbols. So var, however you'd like to say it, that's just representative of a number. Right now it's a representative of 2. So this might as well say 2. It's just this can change. That can, This will change every time this changes, whereas if we just put 2 in here, that's a constant value. That's never going to change. So right now, that equals 2. It just says var. So we can treat that just like a number. So we have var. I'm just going to throw a divide symbol in there. Just the forward slash from above my number pad, and then the number 2. Variable, whatever this happens to be, divided by 2. Because we know that based on how we set everything up, that currently, scale is half of whatever dimensions is. So we want this to be half of whatever this is. Now later on, well actually let's just fix these others real quick. Divided by 2 and divided by 2. So now if I update this, hooray, we have our original cube back. It's fixed. It's now got the appropriate scale on it. And as I scale it up, it works perfectly. See, and it's a better idea to apply it to the dimensions as opposed to the scale, because now I can take my object and I can apply my rotation and scale, and it didn't mess anything up. Because even though my scale reset to 1, my dimensions stayed what they were, and everything works. And I mean, you can get a lot more, like a lot more complicated with the math if you really want. So because that equals 2, alright, so say as I scale this out on the x-axis, I do want my material to grow. This might be something we cover in the next lesson, but I'll just show you an example real fast. So yeah, say I still want my material to grow, but I only want it to grow by like 70% of the size of my cube. Well, I can come here to my x-axis, and what's 70% of 2? Well, 70% of 1 is 0.7, so 70% of 2 is 1.4. So variable divided by 2. Oh, wait, actually I don't have to worry about that because I'm already dividing it down to 1. So basically right now, that equals 1. So the variable divided by 2. So let's go ahead and put this in parentheses so that it handles the variable divided by 2 first. And after the variable's been divided by 2, which is now going to be, an answer of 1, we will take our 1 and multiply it by 0.7, because that'll give us 70% of what 1 is. So now as this grows on the x-axis, it's only going to grow by 70%. And as soon as I went to affect it, you see we actually have a problem here. And that's because it's already showing us 70%. Like basically it's already giving us 70% of the material instead of 100%. So we're looking at, instead of a scale of 1, a scale of 0.7 as illustrated up here. But we actually don't want that effect to take place until we start to scale it. We still want it to be a 1 at default. So I'm going to come down here to our equation, and I'm going to scoot over to this side, and I'm going to add another parentheses on that side. So it's double parentheses on that side, and then come to the end and add a parentheses. So basically now, order of operations says that the first thing it's going to do is the variable divided by 2. And then after it's done the variable divided by 2, it's going to take whatever answer it got from that and then multiply it by 0.7. And then after it does that, it's going to take whatever answer it got from that, and all we're going to do is add the 30% back on. So plus 0.3, because that's 30% of 1. And now it's fixed. So now we have our original texture, just as it was. But if I grab this texture, or this block, and stretch it out on the x-axis, as you can see, the more it stretches, the less we have squares and the more we start to have rectangles. Yes, the checkerboard pattern is still growing, but it's only growing by 70% as much as the cube itself is growing. So in time, it will actually start to stretch its pattern out more and more and more. So there's an example, a quick example of how you can start to apply mathematical functions to start to add a whole lot of crazy detail and capabilities to your drivers. And this is just using one variable. I mean, you can have yourself a big, big, big list of variables where you're taking different values, different properties from all over the place. So yeah, hence the power and potential of drivers. Again, though, this was just a very, very basics. This is our introduction to drivers. All we did was made an object that we can scale without screwing up the material on it. And it's a simple object and a simple material. So yes, this was a very much so a basic lesson, a basic introduction to drivers. And with that, I hope you guys managed to learn a little bit. I hope you were able to see that drivers really aren't that complicated. You just got to pick what number you want to automatically change, pick what's going to cause that automatic change, and then plug those numbers and values in real fast. Again, this was kind of getting to some more complicated stuff at the end here, just, using mathematical formulas and everything like that. But, mind you that based off the dimensions or whatnot, that was our tough math, our variable divided by 2, and that was all it took for that to function 100% fine. So yeah, that's your intro to drivers. Well, the first video for your intro to drivers. Like I said, I'm hoping to do, I don't know, 5 to 10 videos in this series. I want to cover at least the basics, procedural control of materials, procedural control over other objects, and stuff like that. And, setting up custom properties to control things and everything like that. So hopefully they're somewhere between 5 and 10. Hopefully the series won't drag out too long, because I'm also going to be working on my procedural textures series while I do it. So yeah, alright, well there's your introduction to drivers. Hopefully you were able to understand it. If you got questions or comments, just throw them down in the comments section below. As I mentioned at the beginning of the video, if if you notice something wrong in one of my videos, let me know. I don't want my videos to be wrong. So if I make a mistake, I want y'all to call me on it so that I can fix it. Alright, well, good luck with any projects you happen to be working on and stuff like that. And until next time, as always, enjoy creating things your way.